So we officially start our pre-calculus journey with modeling and equation solving. We've been told to solve algebraically, find all the real numbers for which this is true. Now, if it says algebraically, that means you are not going to need a calculator, and your factoring skills are going to be what gets you there. I'm going to go ahead and apologize up front for the poor handwriting. If you don't know what I wrote, because my handwriting is not the best in the world, just say something. Mr. M, what is that? Okay, I'll tell you. It's not a big deal. It won't hurt my feelings. I've known for a very long time that I have poor handwriting. Not to mention, if you've never tried, these panels are hard to write on. So, when you are trying to solve for x and you have things with exponents, your job is to make sure that you get everything to one side. You can't solve by factoring unless it's all on one side. I would also like my leading coefficient to be positive. So I'm going to leave the 6x to the third where it is, and I'm going to move the other two things to the left by subtracting them both. When we do, we're going to have 6x to the third minus 11x squared minus 10x equals 0. The very first thing you should do when you're factoring is, this is always true when you're factoring, is look for a GCF. If there is a GCF, your job is to pull that GCF to the front. Now this time, there is one. All three of these terms have x in common. So I can pull this x to the front, leaving me 6x squared minus 11x minus 10 equals 0. So one of the prerequisite skills was being able to factor quadratics. You have a quadratic now, 6x squared minus 11x minus 10. I don't like the guess and check method for factoring. I can't stand it. I like something that always works, and the guess and check method is just too slow. I use the Lizzie method for factoring. If you're not sure what that is, I'm going to show you, obviously, but if you want to go to YouTube and see more examples, L-I-Z-Z-I-E. Oh, I always cross my Z's. That's how you know the difference between my Z's and my 2's. I always put a cross right through my Z's. So you're talking about the Lizzie method for factoring. And the Lizzie method for factoring works like this. You are looking for two numbers that will multiply to a times c. So first you have to figure out what a times c is. A and c is going to give me negative 60, 6 times negative 10. You then need to figure out what your b term is. Your b term is the one in the middle. That one happens to be negative 11. So we are looking for the two numbers that will multiply to negative 60 that will add to negative 11. This should be the hardest part of the Lizzie method for factoring. It's literally times tables and things like that. So hopefully we've got all those things memorized. This way you're not slowed down. So the two numbers that are going to multiply to negative 60 but add to negative 11 are going to be positive 4 and negative 15. Those do multiply to negative 60. They do add to negative 11. Perfect. Now comes the fun stuff. I love the Lizzie method for factoring. We have an x on the front. Now, you know, when you factor a quadratic, you're going to end up with two sets of parentheses sitting right next to each other, right? So you just go ahead, put your two sets of parentheses now. And what we're going to do is we're going to put an x in the front of both of them. The two numbers we just found, positive 4 and negative 15, they go in these parentheses. But you'll notice, hopefully, that x times x does not give you this 6x squared, does it? So I can't just put that 4 and that negative 15 in those parentheses with just the way it sits. There has to be more to it. So what you're going to do is you're going to give the positive 4 and the negative 15 some space underneath them. That way you can put them as the top of a fraction. And the bottom of this fraction is your a term. That is what makes it the Lizzie method. At this point, reduce your fractions. X plus 2/3 and x minus, what goes into both of those? 3, 5 over 2. And you are finished factoring when you move any remaining denominators in front of the x. I've kind of run out of vertical space, so I'm going to go over to the right. We'll do like this. Whee! Over here. It gives me x times 3x plus 2 and 2x minus 5. It is 100% factored. And at this point, you would tell me what x equals. But you know what? One of the reasons why I love the Lizzie method for solving is because it is over, actually, right here. You could see your solutions at this step. There isn't even a reason to finish factoring. Your job was to solve for x, right? Well, since both these parentheses just say x in the beginning of them, you can see what your three solutions are. The x standing alone outside, anytime it's outside, you guys know what this is going to equal out here? One or two people said it, 0. And then you just tell me the opposite of what you see inside these two parentheses. So we have negative 2/3 and positive 5/2. And there's solving using the Lizzie method. And the reason why the Lizzie method works is because of transformations. We'll be doing transformations a little bit later in the year. I can't remember when. I don't remember if it's this chapter or next, but it works because of transformations. Yes, sir. Kai. At the very beginning of the question, if there was no GCF, then there just isn't one. The only reason why the GCF mattered for this one is, one, the Lizzie method is for quadratics, and two, this GCF produced a solution because there was an x outside. Now let's say for a moment, let's say the GCF didn't have an x in it. The GCF was like a 2 or a 6, and that number was sitting on the front. That number would not develop a solution. Solutions only come from x's. So if the GCF is simply a number, it's a number. Woohoo! It won't affect your answers. But if it's 2x, okay, so what if it is 2x? What color was it? Let's just pretend it's 2x. Right here, your job would be to tell me what x would have to equal for this to be true, right? Because you're trying to make each part equal 0. Well, if you divide by 2, you're still going to get x equals 0, right? Anytime there's an x outside of the set of parentheses when you're factored, its answer is automatically 0, regardless of what number is sitting in front of it. One of the things I like to do to my Algebra 2 students, because I teach them the exact same thing, on their test, I give them something that's already factored. And then I say, what are the solutions? And it's factored, right? But I put a negative fraction in front of the x just to watch their ears smoke. But it doesn't affect the answer. It's still 0. Cool? Okay. All right. We good for the next example? Moving on? All right. And then we will scoot on down. So this one, we've been told to solve it both algebraically and graphically. So I will be showing you the graphing calculator after I do this by hand. So algebraically. So that's how you spell algebraically. So I spelled it incredibly wrong on my board over there. Whatever. I don't know how to spell very well. I'm going to be real with you. I studied math because I like it. Same idea. We're going to bring that 10 and that negative 4x, we're going to bring them to the left. That way we have a positive leading coefficient. So when we move them over, we're going to get x squared plus 4x minus 10 equals 0. And you know what? Shucks, shoot, darn, that doesn't factor. So how are we going to solve that? Somebody whispered it. You could say it louder. Anybody? Yeah, quadratic formula. Yeah. Look, I expect you guys to talk to me. This is this is my favorite stuff to teach because usually the students interact with me. So you guys feel free to jump right in there and talk to me, okay? Yeah, the quadratic formula. Who likes doing the quadratic formula? Not me. I hate the quadratic formula. It sucks. It's got so many moving parts. But we're going to do it because we were told to. Let's go ahead and fill out this. So many moving parts. All right, so we're going to make sure that I always show all the work for this. I try not to do any of the quadratic formula in my head when I'm first writing it. This just got too much going on. So I will show all of my substitutions with parentheses. So I have negative. My b value is 4. Still 4 squared. Our a value is the one in front of x squared. And c is negative 10. So much work for this. Also, you guys have the ability to write smaller than me, so there's a chance I'll run out of space and have to erase what I have to continue for space purposes. So just make sure that you pipe up if you needed something still that I erased. I'll bring it right back. So they give us negative 4 plus or minus. Everybody in the room knows how to use a calculator. So we have 16 plus 40, 56. That's what it is, but would you believe on my paper I have that 16 plus 40 equals 80? What's wrong with me? Well, anyway, 16 plus 40 is not 80. It is 56. I'm not really sure where the 80 came from in my notes. Oh boy, look, that is not fun, is it? 56 is not a perfect square. So we would need to reduce this radical. Yeah, okay, well, what perfect square goes into 56? 9 goes into 54, not 56. There is a perfect square that goes into it, though. 4. 4 is the only one. 4 goes into that 14 times. Negative 4 plus or minus 4 times 14 all over 2. The square root of 4 comes out. So it's negative 4 plus or minus 2 root 14 is stuck inside all over 2. And the last thing that we have to do is reduce this fraction because we can. So the negative 4 and the positive 2 right there can both be divided by the 2 on the bottom. Gives us negative 2 plus or minus the square root of 14. Those are your two solutions. If you wanted to know them as decimals, you grab a calculator and ask it, what is negative 2 plus the square root of 14? What is negative 2 minus the square root of 14? So quadratic formula, not fun, but questions, comments, concerns on the quadratic formula? No? Everybody's cool with that one, right? All right. Well, let's do it the easy way with technology. Go gadget graphing calculator. So the way that I'm going to do this one is I'm going to go up to this top left button that says y equals. And you won't have anything on there probably, so let me go ahead and get rid of those. There. You're going to type two different equations. The first one is the left side of our question, which was just x squared. So you press x, and your calculator actually has a squared button right here. So it says x squared. Now you just press the down arrow to move to the next equation, and the next equation is going to be the one that was on the right side of the equal sign, the 10 minus 4x, which is a straight line. So 10 minus 4x. Now, you saw that I already had equations on here, right, when I opened this program? I already had equations on there. So I may have played with the graphing window. I may have played with the scale. We're not sure. So what I do every time I graph something, before, right here is the button that says graph. I generally won't go to this graph button. Instead, what I'll do is I'll hit zoom and then the number 6, because that takes me back to a standard graphing page. Because you never know if you played with the scale or if you played with, you know, the x's go from negative 10 to positive 30 or something like that. So I just hit zoom 6, and it'll graph in color. Whee! So there we have our parabola and our straight line. The quadratic formula gave us two solutions, didn't it? The solutions are the places where the graphs intersect one another. I only see one answer there, but there should be two. The reason why is because the answer up here is currently not visible, so we do need to play with the window a little bit, and that's what it's called. This that you're looking at, how far the x's and y's go is called your window. We need to change our window. The problem that we have right now is that my y values did not go high enough. So I go to window, which is right here next to y equals, and I need to change the y values. So I'm going to scroll down. The small y was all the way down to -10, was fine. Our problem was our y maximum was not big enough. Now, I don't know how high to take it. This is an educated guess. You saw it to 10. It looked like to me that 20 might work. Just a total educated guess here. The more you play with these things, the better you'll get. So I'm just going to say 20, and I am going to change my scale. This scale controls how many tick marks you have. I like to have generally 10 tick marks up and 10 tick marks down. So this is just a me thing. The distance between 20 and -10 is 30, right? Okay, so if I wanted 10 up and 10 down, then I would say whatever the distance is, 30 divided by 10, 3 divided by 2, 1.5. This is just me. You don't have to do that. But my strong suggestion is do not have all 30 tick marks, the more tick marks that it shows. So if your scale is still 1, the slower it will graph. And then you hit graph after that. Boink. Let's see. Let's see if I got enough Y's. Crud. Still not enough Y's. You see, educated guess. It is what it is. I could take it to 30 just for speed purposes. I'm going to take it to 40. I think 40 is going to more than pass it. So back to the window. Take it all the way down or all the way up to 40. And you know what? Let's just divide by 10. Distance between 40 and -10 is 50. So I'll just say 5. I'll just have a total of 10 tick marks now, up and down. Then you hit graph again. Give it to me now. There it is. We can see them both now, can't we? This graphing calculator has the ability to calculate, and I'm using that term on purpose, this graphing calculator has the ability to calculate where those two intersection points are. So what you're going to do is, Willie, do you have the note packet? The packet? No, I'm saying, but you're not. You wanted to freehand all the notes? Okay, all right. I just want to make sure you knew there was a packet. So what you want to do is calculate these two intersections, and I'm using that term because I know it's small, but this little blue word says calc. We're going to calculate the intersection, and the graphing calculator makes the blue commands work by pressing the blue button first. So we go second, calc, and we are looking for an intersection, which is number 5. I only graphed 2 curves, technically 2 lines, whatever. I could have graphed more, right? I could have had 4, 5, 6 things on the screen. So because of that, when you go to find an intersection, the calculator says, hey, which 2 are you trying to find the intersection of? I only have 2 on the screen. So it's asking me, was this the first curve? And I say yes. And it says, was this the second curve? And you say yes. And if you only ever have 2 on there, it becomes quick. Second, trace, 5, enter, enter. It just becomes a pattern that you've memorized. Now it's telling me to guess where the intersection is, so I'm just going to scroll left until I get close to it. And then when you think you're pretty close, you just hit enter. And it will give you one of your answers right there. -5.74-ish. Yes, sir. You wouldn't have been able to get close enough to it. It might have worked, but it might not have. It depends on the complexity of the equation. So the question was, why did I have to actually zoom out? And that was only so I could see where it was. These are both pretty simple equations, so there's a really good chance that it would have gotten it right, even if you hadn't been able to see it. But if they're really complex, you need to get as close to it as possible, because the calculator is not actually, quote-unquote, calculating the intersection. It's estimating the intersection using some very complex mathematics. And when the equations are simple, the answers end up being dead on. But when the equations are ugly, which you'll see at the end of the year when we have to use the graphing calculators, it gives us solutions that are approximate. And had you done it by hand, you would have gotten a more exact answer. So I just like to be able to see it. And if we want to find the other intersection, you just go through the process again. Second, trace, intersect. second, and second trace, because that's how you get calculator. Second, trace, intersect, yes, yes, and then scroll over to the other answer. So it becomes really fast if you only have 2 on the screen. Scrolling is a pain in the butt. Whoa, pressed it too many times. And there's your other answer, about 1.74-ish. This was the easy way. Once you've memorized how to use the calculator, this is really fast. Simple. Okay. Now, there's not really any notes to do unless you wanted to write down how you did it. So you can, oh, you know what else you could have done? You also could have, this first step right here when I moved everything to one side, you also could have just graphed that quadratic and figured out where it crossed the x-axis, which instead of using intersect, you would use the command 0, so second trace 0, because they're called zeros as well. So the calculator can do a lot of things. I'll show you how to use that one at a later point in time. So fundamental connection. If a is a real number that solves the equation f of x equals 0, then these 3 statements all say the same thing, and a means just any constant. A is a root or a solution of the equation. So you see roots are solutions. They mean the same thing. A is a 0 of y equals f of x. So basically roots, solutions, zeros all mean the same thing. Answer is what they mean. A would be an x-intercept of the graph, y equals f of x. Meaning, right here, if I had graphed y equals x squared plus 4x minus 10, and I asked the calculator where does it cross the x-axis, those would have been my solutions, also known as my roots, also known as my zeros, because I found my x-intercepts. So all those terms mean exactly the same thing. Comfortable with that idea? All right, and we're going to clear. Maybe. Come on. Let's try again. Oh, yay, it worked. Okay. I thought it was crashing. That was going to make me sad. Hey, look, a word problem. The engineers in an auto manufacturer pay students 8 cents per mile plus $25 per day to road test their new vehicles. I wish I could get paid like that. How much did the auto manufacturer pay Sally to drive 440 miles in one day? And John earned $93 to test drive a new car in one day. How far did he drive? We need equations. So we're going to be turning these real-world problems into math equations and solving. Basically, what we need to know is how do we get paid? So our pay equals, well, we get paid 2 ways, by mile and by the day. The nice thing about this question is that both A and B are talking about one day. So we only have one variable. So we take the $25 we got paid that day, and we would add our 8 cents per mile. And the per mile is the thing that can change. So 0.08x or m for mile, whatever variable you want to use, it doesn't matter. And now that we have an equation, we can solve questions A and B. Eek. My handwriting is getting worse by the moment. I'm sorry, and that's because my pen has started to squeak when I write with it, and it's driving me nuts. So I'm trying not to let it squeak. Oh gosh, that's terrible. Okay. We want to know how much money Sally made when she drove 440 miles that day. So don't let this be hard. Literally just plug in 440 as the number of miles, which is x. So Sally's pay is her $25 for the day plus 0.08 times her 440 miles for that day. You grab a handy-dandy calculator and you type it in exactly as you see it, 25 plus 0.08 times 440. And I have, assuming I didn't goof it up, that Sally made $60.20 that day. Okay, I had a nod from the crowd, so that works. $60.20. Go Sally. Now, John drove an unknown number of miles. That means we don't know what X is, but we do know what John's pay is. John got paid $93 that day. Well, we know he drove longer than Sally, right? We know that. So his pay is 93, and now we just solve for X using PEMDAS in reverse order. Should be pretty simple stuff here. We're going to subtract 25 from both sides. What does it give me? 68? Yeah, it feels right. 68 equals 0.08x, and then divide by 0.08. Whole number answer, 850 miles. It's a long trip. That's farther from here to Nashville. That's where I'm from. I make that drive every summer. Is this groundbreaking stuff, or we're all pretty comfortable still, right? It's not too bad. I mean, that's an Algebra 1 question, to be honest with you. So how about we make it not Algebra 1? Let's see a graphing calculator fail to do its job. So it says, look at the graph of this thing. That means we actually need to graph it, and we've been told what window to use, right? This is your X's, and this is your Y's. All right, so we've got to go back to our Y equals. I have to clear these things. And it says Y equals 3 minus. Now, on the notes, I have a really pretty stacked fraction, right? The graphing calculator can make stacked fractions. You want to use stacked fractions, meaning something over something else literally, instead of using the slash. Because when you use the slash, you have to become a master of using the parentheses to understand how the calculator thinks. Instead, I'm going to hit this math button, because this is where I find a lot of my structures. Math. And it is not frac. It's this one right here. It's the frac menu. So I hit left, and then it's N over D. Numerator over denominator. Enter. And it makes a stacked fraction for me. Math. So you're going to hit the math button, and then you hit left to go to this fraction menu. Older calculators might not have this fraction menu, but they should still be able to create a stacked fraction. I just can't quite remember where it is. There's a shortcut for it if you have an older version of the calculator. So if you don't have this fraction menu, then you're going to want to go to YouTube and things like that and figure out how to use that calculator. It has the capability, I just don't know it. So you'd hit left, and then you would hit enter on the stacked fraction. This one says 1 over, and then we have a square root. Square root is right here. It's a blue command. So second pops the square root for me. X squared minus 1. X squared minus 1. No parentheses necessary. And we go to our window. This right here next to your decimal point, just like on a scientific calculator, that is your negative symbol. If you use the minus sign instead of the negative symbol, you will get an error. And usually it says syntax error. This is your negative sign. So negative 4.7 to positive 4.7. They didn't tell me what scale to use, so I'll just stick with 1. Y values negative 3.1 to positive 3.1. They didn't give me a scale to use, so I'll make the scale 1. And then we get to hit graph. And we get to see what this thing is doing. Graph. Did it hit the x-axis? No, it did not. However, that is only because the calculator is limited. It does not have the ability to show you vertical lines. And this thing's solutions are approaching a vertical point on the graph. So even though the picture does not look like there's a solution, there is.
Can you go back to showing what the window was?
The window is actually just this, but yeah. Yeah, so they told us specifically to use 4.7 to 4.7 and 3.1 to 3.1, you know, positive and negative, obviously. We good?
Why are two of them negative?
The negative 4.7 and the negative 3.1? Well, they have, okay, so this negative 4.7, if you look at the graph, is over here. So basically you're just telling it how far left and how far right to look. So that's negative 4.7 to positive 4.7, and then you have to tell it how far down and how far up. So we went down to negative 3.1 because they told us to, and went up to positive 3.1 because they told us to. So that's all you're doing. You're just telling it left, right, up, down. That's all you're doing. So let's actually find the solutions by hand. So it looks like there aren't any, but let's go ahead and set it up. 3 minus 1 over the square root of x squared minus 1 equals 0. What I would do is I would move the fraction to the other side of the equal sign. Because what I'm trying to do is I'm trying to get the x's all by themselves. When you look at this, we go, oh, goodness, wow. We don't like fractions. So we cancel the fraction. We cancel fractions the same way all the time, and that is multiply both sides by whatever is on the bottom of the fraction. So we're actually going to be multiplying both sides by square root of x squared minus 1. You're going to distribute it on both sides. On the left, you now have 3 root x squared minus 1. On the right, you just have a 1. And now you just use PEMDAS in reverse order to isolate the x. So the first thing we're going to do is not cancel the radical. Don't do that first. You don't cancel radicals till they're alone. So I need that 3 to go away. I'm going to divide both sides by 3. So yeah, I created another fraction, but that's okay because I'm trying to get x by itself, and we're going to use a calculator anyway. How do I cancel a radical or square root? Anybody? Shout it out.
Square both sides.
Yeah, good. So we're going to square both sides. Let's raise both sides to the second power to cancel my radical. That leaves me an x squared minus 1. I have to scoot to the right. X squared minus 1 on the left, and on the right side I have 1 over 9. Can add 1 to both sides. Oh, as I had to square the 1 and square the 3. Square the 1, so 1 times 1, and square the 3. 3 times 3. Add 1 to both sides. What is 1/9 plus 1 as an improper fraction? Anybody know? 10/9. Good, because it's 9 over 9, right? So if the 1, think of it as 9 over 9, I now have 10/9, and you are going to cancel that square with a square root. So the exact opposite of what we did a moment ago. However, one thing you have to remember, when you cancel a square with a square root, just like that, that will produce a plus or a minus. So there are 2 solutions, plus or minus the square root of 10 over 3, because I took the square root of the top and the square root of the bottom. So there are 2 solutions, plus or minus square root of 10 over 3. Neat, huh? So the calculator couldn't show you those solutions because at those solutions the graph was approaching vertical. The graphing calculator can't handle vertical. You just can't do it. And you know what? Let's not worry about the last one, because it's not that important.